So hopefully everybody's back from break. I am going to share my screen. And what I've got is the SEC 555 free virtual machine. And the login for that, by the way, is lowercase SEC 555. So just log right into it, student SEC 5555. This is also the virtual machine later that when we say we're giving out 2 free 555 VMs, that's this one. So I'm going to full screen this just so that we can see a little bit better here. So in here, if you were to open the browser, this is how you would access the free labs, which is not what we're doing for the breakout session. I'm just showing that real quick. So you can see 555, and there's 2 labs in here under this. So later when we talk about the free labs, it'll be right there. I'm gonna close out of that. Instead, what we're doing is we're gonna be doing terminal. Oh no, command line. I know, it'll be fine. Here's what we're gonna do. In this folder, I've got a whole bunch of configuration files. I'm gonna talk through them and kind of the logic of what you would use them for. Because remember, this breakout session is really about making alerts easier to handle, but I'm going to even abstract that farther than that. It's data. Like if I bring in Windows logs, if I bring in IDS alerts, if I bring in DNS, maybe you want to take that raw data, even when it's parsed into fields, and make it better. So that's kind of the logic we're doing here. But the use case, one of the best use cases you can possibly have is your SOC, or even if you don't have a SOC, you have alerts. Alerts are coming in and you're supposed to look at them. Can be intimidating because the list of alerts goes on and on and on and on and on and on and on. So what I want to do is walk through how to make that a better process, a more efficient process. The password is SEC555 for the 555 breakout. The password is security 530 with capital S for Ismail's breakout. I'll put this in Discord real quick. So SEC555 VM password is SEC555. SEC530 VM password is security 530. There we go. So in here, let's just imagine for a second we're getting alerts in, say you've been attacked, there's been a phishing attempt, there's been, okay, something came in. What I want to do always, in my opinion, is I want to take that alert data and I want to give it more context, because if I can get additional data about the alert, like instead of an IP address, what if I have a domain name? Like, and it's a randomly generated long domain name, like a DGA, a domain generating algorithm name. Well, in that case, what I can do is I can assume that's bad. Randomly generated long domain attached to an alert, but before all you had was an IP address. So what I'm doing here is these are Logstash configuration files. So you wouldn't need Logstash for this tool. I like to demo with Logstash because I can put Logstash in front of Elastic, Splunk, QRadar. It can front end effectively anything. But even if you're like, I'm never going to use Logstash, that's fine. Mimic the same concept in whatever your tool is. So let's just kind of start with some basics here. I'm going to show you kind of a completed start to finish kind of example, and then we'll kind of work backwards and go to each technique individually. So we're going to go to the enrich folder, and I'm going to play with this. The first one I'm going to run is just this field list, which shows us what data we're dealing with, and I'll open it in a second and show you it. While that's running, I posted the download links in Discord, and later if I post this recording, it'll be underneath the video. I did put 2 links for the Discord channel, and for YouTube, I'll make sure whatever link I post, it's the correct link. So hopefully that downloads. If not, you're following right now. You might just have to watch for now and then download later, but we'll try to get you all squared away. John, thank you for monitoring all that for me, by the way. So this is running, and I'm going to go ahead and full screen this for a second. And it's just about done. And what this is going to do is it's just going to print out the data we're dealing with. I've got 2 alerts here. So again, I'm going to show the completed kind of enrichment pipeline, and then I'll go back and show individual techniques. So here we're dealing with 2 alerts. We've got alert number 1, which is, hey, guess what? You've got some type of weird hex ASCII PDF dictionary entry. It's a network Trojan, maybe. And it's sourcing from the internet, but it's going to an internal. How did that happen? How did something from the outside connect inside to, say, like a workstation or a server? Is this a web server that I own? No, this is actually a workstation. What's happening, and this is true of both commercial and open source tools, the way the alert signature is written, the direction of the flow it's investigating might be reversed, in which case the source IP and dest IP are actually flipped. So one way as an analyst you might try to think about this is the low port is usually actually the destination. So this is actually the source connecting out to, in this case, the destination port of 80. So their source and destination are flipped in this example. I didn't flip them. It's just the way the alert engine works. So some weird PDF thingy versus our second alert down here. We've got a exe or DLL file has been downloaded. It's a possible privacy violation. Again, we got the source and destination flipped in this one as well. And your job is, are these evil? Are these malicious, suspicious, and benign? Or benign? The very concept that you got these alerts usually means something bad happened or that they're at least suspicious. What I want to do is use enrichment techniques to automatically shift this to either benign or malicious. So, and by the way, let me open this config file just so you can see what all of these, you have the complete code. So you can see here at the very top, once this loads, is I'm showing I'm starting with 2 alerts, just like they would come from Snort or Suricata. And then I'm just doing regex parsing right here. If you're not used to regex, you're like, no, it's not that bad. That's all I did with this one. Next, though, I'm going to run something a little bit more fancy. I'm actually going to go through the full enrichment gambit here, which is technically not all the things I would do. I would actually do more than what I'm going to show. I'll talk through this. I'll let that start to run just because it takes just a little bit to start up. But look at this. So we start with the same 2 alerts. I parse them out with Grok. But notice in this time, I'm adding more to the config. I'm doing a geo IP of the IP addresses, both the source and the destination, because it's IDS alerts what we're playing with right now. And so sometimes they're flip-flopped, and the external IP is actually a source IP. So I'm running against both to grab ASN and BGP information. That's not city, state, country, by the way. That's ASN, autonomous synchronous numbers. That will show like BGP routing numbers in the entity that owns or hosts that IP space. That's going to be helpful. I'm also getting the standard city information. That is city, state, country, what we're used to getting with like the pretty pew-pew maps. I'm also doing basic tagging. Like this is actually one of my favorite things. Hey, if it's starts with a 10 dot or a 192.168 dot or this 172.16 through 31, it's an RFC 1918 private IP. Well, if the destination is an RFC 1918 IP address, it's an internal destination. Otherwise, let's treat it as an external destination because it's probably external. In my full configs, I actually go a little bit farther because it could be a multicast address. It could be a broadcast. This one, it's either internal or it's not. I usually kind of break them out. Internal, multicast, broadcast, external. So we can do that. I did the same thing for source. And here's where some of the magic starts to happen. Let me talk through this one first. What this is doing is it's trying to go from an IP address to the DNS that the machine that connected to the external IP address resolved to. Now think of this like this. I do nslookup google.com. Now, if I were to browse to google.com, my machine would go here. Well, if my machine's going there and I get an alert about it, I want to be able to go from the IP back to the name. Well, if I do an nslookup of the IP address, though, watch what happens. It resolves to this. That's not google.com. Nope. Because this is a reverse lookup, a PTR record. And so the reverse lookup, one, is actually really slow. If you're handling millions or billions of logs a day, this is a really expensive lookup. Two, it's not accurate. It is not accurate. Therefore, I don't like doing DNS lookups within any type of log aggregation or SIM tool. There's edge use cases where it's actually really helpful, but as a general rule of thumb, I don't want to do it, so I don't. So instead of doing an actual DNS lookup with the SIM, which you can do, I do cross correlation with the SIM. So in here, I have logs normally that would go into a tool called Logstash, which would then write them to a backend storage system called Elasticsearch. But in this case, I'm assuming I have DNS logs collected and in Elasticsearch. So what I have Logstash do as alerts come in is it actually queries Elasticsearch. And it's saying, hey, do you have in your DNS logs something that had an answer? Basically, it was resolved and had an answer of the IP address in the alert, that source IP, if the external IP is the source. And if you find it and there's a match, please pull in the query field. That is much more useful. It's much faster. And I can now have the actual DNS at the time it was requested. And you could make this more specific. And I could do another AND that said it had to have sourced from this client, which would in this case be the destination IP. You can flip-flop them. And by the way, anybody who is downloading but it's taking a while, Dropbox is by far the faster download. If that's not working for whatever reason, just follow along for now, and you'll be able to do this later when you get the VM downloaded. So from here, I'm also pulling in Sysmon data. Now, Sysmon, or if you had something like EDR, I don't care, somewhere where I have process command line creation activity. Because what I'm saying here is, well, if I have traffic that's going from this source to this desk to this source port to this destination port, that's called a network socket. I want to know what process kicked off that socket. Sysmon event ID 3 has that information. So I can, again, auto-correlate to the socket and pull back in the process, the parent process, the user, the domain, and whatever other information you want. So I'm doing an auto-correlation here, and I do it one more time where I try to figure out, did this create a file? Sysmon, again, has file creation events. So pull this in. I flip it because, again, I don't know if the external IP is in the source or destination field. So this all is the same code, just assuming that if the source or external IP was in a different field, it just does it the other direction. So that's why it's wrapped in an if statement. Now let's go back and look at our log here for a second. Remember our original one. Now the first alert would look like this. This is all just the first alert. It's a lot more details. In fact, I can't fit it on one page without zooming out, and I'm not going to do that. So this was the, what we saw? This is the weird PDF dictionary hex ASCII. Okay, well, notice I've got more information. Originally, we could see this external IP. Okay, but now with that geo ASN, I can see this is hosted in Amazon. Malicious, suspicious, benign, just with that. Still suspicious. Why? Well, because it could be Amazon AWS hosted. Could be an attacker who is using stuff like their command control is in Amazon land. So cloud providers, it doesn't really help me. If that would have said something like Netflix, I've never seen an alert where Netflix is actually attacking me. Could it? Yes. Have I ever seen it? No. but I've seen a lot of alerts from Netflix because encrypted content or compressed content, for whatever reason, matches an alert and it false positives. So the ASN can be helpful. It gives me context. I also have the city, state, country, United States, Virginia. That's not all that helpful, in my opinion, except for like impossible time traveling logons, but that's not what we're having here. How about this? Let me find this. I did that lookup to DNS logs, and I found that this was reaching out to, see, now there's so much information, I'm struggling to see this one. Where's it at? Here it is. Query, track my package -com.biz. Okay, malicious, suspicious, benign. We went from suspicious to a little bit more towards malicious, because that's com.biz, a double TLD. That's kind of sketchy. So I didn't have that information before, so this one's kind of interesting. Let's keep going. Who pulled this down? Well, it was me. You're looking at them, right? With my Azure Active Directory credential, my cloud credential. What did I pull down? Well, let's see if it pulled that in. It did. Shipment notification 555 from Microsoft Edge on my machine, Lightforge desktop. And this one is not something I'm done with. I need to manually review this. But as an analyst, if the alert hit my desk with all this information, that's way more efficient than if it just had the bare minimum information we started with. So alert number one went from to, yeah, it's definitely suspicious. We need to go look into that. Let's look at alert number two, and then I'll start breaking down the individual techniques. Alert number two was that weird exe DLL download, which is very generic. See a lot of false positives with this one, unless you're controlling the flow, like only EXEs and DLLs can come from like a proxy, but a lot of companies aren't using those. At least they're not locking down to them. So I see this all the time. So usually we end up having to disable it because it has too many false positives. But if I'm upgrading the alerts, watch what happens. Well, where did they download from? This external IP. That external IP is Google Inc. That's the ASN. Still could be suspicious, Justin. Google has a cloud. Totally agree. That's not enough information to say it's malicious or benign. How about this, though? The DNS record that we tie it back to was dl.google.com. Hosted in Google, and the domain we're connecting to is Google. Do I think a Google domain is likely to attack me? I personally would lean towards this is starting to look benign. Could I have someone sharing a file over a Google domain that's malicious? Yes, but this isn't a like Google Drive share. This is dl.google.com, which is the download site for Google executables, like for Chrome setup, things like that. So I don't think so. Who's doing this? Still me with my Azure AD account. But let's finish this out. I'm using Internet Explorer to connect to dl.google.com to download Chrome setup.exe. Malicious, suspicious, benign. Benign. I'm using Internet Explorer for the one thing it's good for, downloading a new browser. But do you see the difference here of the normal bland alerts versus the log enriched context upgraded alerts? We can do false positive, and we can help our analysts out substantially by doing this. So the rest of this workshop, we kind of started with the end, and now I'm going to walk through how to do some of this stuff. So in here, by the way, there's multiple config files here you can kind of read through, but I'm going to back up because I've got most of the stuff I want to talk about here. And specifically this tactical logstash folder, that is actually a GitHub project that I host. I'm going to show you this. It has tons of configuration files and demos. So github.com, HA Security Solutions. This is where we put a lot of our free stuff. And this is the Tactical Data Handling at Scale with Logstash. The name is super long. I apologize. So in here, I've got examples of how to get data from the cloud, handle firewall key value pairs, Ceph formats, do enrichment, you name it. Basically, this is demo files based on a 16-hour Logstash online course I have, but I still release these for free because that's just how I roll. So what I'm going to do is just walk through the enrichment ones. So let's have some fun here. Let's start with DNS. So in here, this is true DNS. I guess it's easier if I do it here. This is something I normally would not want to do, but what I could have is, oh, I got to fix this formatting. Come on. We need consistent formatting. I do spaces too, personally. See, looks so much nicer. So what I'm going to do is this is going to let me type in an IP address. I'm going to copy that into the domain lookup field, and then I'm going to replace it with whatever the lookup happens. So this is effectively a DNS lookup if you ever wanted to do it. And Justin, I thought you said you don't ever do that. No, I said I don't, as a default, do it. There are some edge use cases where this can be helpful. One example, let's assume that a machine connects to HTTP 1.2.3.4. This, if it's an internet IP address, is what we refer to as a naked IP address. It doesn't have its DNS close on. I didn't come up with that term. I don't like it, but that's what it's called. So in this case, I would do a reverse lookup on something that's a naked IP request because I want additional information. I would also do a GeoASN because I want that to tell my analyst why did we reach directly out to an IP address. That's one use case I will do this. So it's up and running. It's kind of doesn't stand out really well, but we see this. That means it's ready for me to type. So 8.8.8.8. And notice that's what I typed, and it did a reverse lookup to dns.google.com. Okay, 1.2.3.4. Oop, typo. 1.2.3.4. I did the typo again. No PTR record for that. It didn't get replaced. Let me do this example we did earlier. Let's copy that. Paste that. Notice, there it is. It pulled it in. So simple DNS reverse lookup. Let's try something different and cooler. I'm going to do this translate one. Open this up, translate. There we go. So again, it'll let me copy. In this case, I'm going to pass it a domain. I'll start this up, and then I'll talk through this. So what's happening here is it's going to let me pass a domain in, and it's going to do a lookup against the Alexa top 1 million. Now, I would have to have downloaded this file. I do have that in the tactical folder. There's a, where's it at? This bash script will actually download it for you. It'll download it, and it'll actually reverse the order of the fields because we need to. I use awk basically to flip field 2 and 1 because I want them in the opposite order. Don't worry about it. You can just run it. The only thing you would want to change is where you're downloading it to, right here. And then I translate it, pull it in, and if it's found, I put a rank. If it fails, I say, this is not a top 1 million domain. Tag it, and that information is now useful for me. So let's try this out. Google.com. Google.com is ranked #1 in the top 1 million, and it's now tagged as top 1 million. You're in the middle of an investigation. You found an alert. You've got domains. Is it a top 1 million domain or not? Well, if it is, it's less likely to be malicious. It still can be, but I can do the magic 8-ball. Is this malicious? Signs point to no. Well, start looking in the non-top 1 million domains first for evil. If you don't find anything there, fall back to the top 1 million. You can also use that tag to figure out how much enrichment you want to put in. If it's not a top 1 million domain, throw the entire book at it. It is a top 1 million domain, and maybe it doesn't matter as much. All right, let's try something different. Let's do sans.org. Now they're ranked 27,268. All right, whoo, go sans. Let's do my company, hasecurity-solutions.com. Oh, that's embarrassing. We're not a top 1 million domain. Oh, not yet. Yeah, probably not ever. Our domain really isn't that great. Most of our content that you actually care about is on GitHub or YouTube and things like that. So, all right. We can handle it. But you can see it's tagging properly. And if it's in there, it'll pull back a rank. So that can be any file. This technique works well, maybe up to files that are 100 meg. I don't know if I would go past that. Like you could download threat feeds that are 100 meg or less, and it would work well with this. Like IOCs, things like that. Here I did the Alexa top 1 million. This really is actually really small. So don't go past maybe 100 meg. It won't work all that well. Let's do something different. One of my favorites, this is the querying a HTTP API. So I'm going to use a tool called Freak Server and Domain Stats. Now, to run that, I've got this run file. You could just run it with bash and it would do it, but I want to show you what it's doing. It's basically starting 2 Docker containers. Just go ahead and start one. Freak Server. Oh, it started in the background. So if that happens and you want to stop it, you can just do this. I'm actually purging it. Goodbye. And I'm assuming domain stats is probably running too. Goodbye. And now rerun my command. Of course I did. Copy, paste, there we go. It's now running in the background. I can prove it's working. One, you could do this test. I'm just going to run this. Localhost. I have it listening on 10,004. Measure to, google.com. This is kicking back a natural language processing score, an NLP score, on how normal or not normal a domain is. It's just using the English dictionary by default, so it's not going to score correctly, but I'm showing how when logs come in, I can reach over to this web interface and pull back data. This would work for commercial tools, even like RiskIQ, like online passive DNS. They have a REST API you can authenticate and pull data from. So the goal is in your log ingestion pipeline or your SOAR platform, wherever you're doing this, as you're trying to look at a string like an IP, a domain name, whatever it is, I can cross-correlate that via a web API call. So I'm going to go ahead and finish this out by getting domain stats up. Copy, paste. I'm going to go ahead and real quickly run the test script just to make sure they're both functioning. We're good. It pulled back a freak score. It pulled back a domain creation date. So in domain stats, what I'm doing is I'm trying to figure out if a domain is new, like fresh off the car lot, it's got that fresh car smell, or if it's old. And I actually want it to be old. Because I don't know about you, but if you just buy new cars all the time, you'll be broke. Just word to the wise, life choice. Buy the used car, buy a 2 or 3 year old car, and you'll save a bunch of money. Okay, bad analogy, but concept here is domains we're connecting to, if they're old and they've been around for a while, they are safer than something that was created right now. Like domain generated algorithms, randomly generated domains, they usually have a lifespan of 24 to 72 hours. They're registered, they're used to attack you or command control, and then they're decommissioned. Ta-da, right? Oh, okay. So I'm going to run logstash -f, and I'm going to point to, in this case, this must be in my tactical folder. And this is probably, yep, there we go. The HTTP enrich example. I'm going to bring that up so that we can see it. There we go. And notice this is literally using the HTTP plugin to make a HTTP call, in this case to our running Python REST API services. And it's going to pass whatever I give it, a domain name, to these 2 APIs and pull back values, specifically a creation date and a frequency score. So once that's running, I'll do that. But keep in mind, this does not have to be the 2 HTTP services I'm using. You have a Palo Alto or a FortiGate or a checkpoint, a sonic wall, maybe not a sonic wall. If I had those running, and let's say I know for a fact this alert coming in, it's bad, and you want to block traffic to that IP. Be very careful if you're doing this, by the way. All of those have HTTP interfaces, meaning I could pass with Logstash an authentication token that says this external IP, shun it, block it. And I can actually do that programmatically in something like this. Same HTTP plugin. Do google.com. Ta-da! Notice pulled in, google.com. That's just what it's using for the plugin. And let's try hasecuritysolutions.com. Ta-da! So pulling in creation dates, and we're also getting frequency scores. That simple. Lots of use cases for that HTTP plugin. Let's see what else we got for you. Okay. In here, well, let's do the GeoIP. Before we get too far, I actually have a README of what I'm supposed to cover. I'm going off script and just doing whatever I can. So let's do the GeoIP just to get that one out. That one's pretty simple. GeoIP. Again, I think that will ask me to put an IP address, and then it will do the geo lookup. Now, this one's hard-coded. Generator will just automatically play the data. If I were to change that to standard in, like this, it would let you type an IP and then run it through. This is running against both city and ASN. If you wanted to try one or the other, you could comment out or delete these sections. So we'll see this here in a second. I've covered that one, that one, that one. The SIM lookup was the Elasticsearch lookup that we did. So time permitting, I still have to do a few more. There we go. Ta-da. So this is what we gave Logstash, and it appended this extra data right here. That's a lot of extra information. What I specifically like the most is this ASN. I find that very helpful. Country codes, those can be helpful too. So, okay. Up next, let's actually do the memcache one. This one's really cool. This is kind of an advanced technique. But in here, and this is all documented, I've got this run script which will start memcache. It might already be running in the background. We'll find out. It's already running. If you want to start from scratch, just delete it. So I'm spinning off memcache, which is basically a memory lookup. You can give it as much memory as you want. This is just given a small amount. So right now it's up and running, but there's no data in it. And what I'm going to do is I'm going to run this send memcache data script. It's going to give it an IP of 10.5.55.3 and 10.5.55.2. And it's going to mark them as being on a threat intel feed with a score of 32 and a score of 99. So this will make sense here in just a second. Stored. So now memcache has that data. Now what I can do is I can run a query against memcache and see if it can do this lookup. Memcache has been one of the best things I have implemented in my environment because we actually do cloud hosting of the open source Elasticstack as a commercial offering. And so we have clients that are like 300 employees up to clients that are, well, the most recent one is, I don't know their employee count, but the amount of data they send per day is like a terabyte, almost 2 terabytes of data per day. So they're a huge environment. And if I'm doing a bunch of lookups and you have like, say, 2 terabytes a day of data, your events per second is really up there. DNS lookups, geo lookups, even that file top 1 million lookup can start to get expensive just because of the volume. So what we do is we memcache front end the data. So in this case, the top 1 million goes into memcache and we do the lookup there. And we actually programmatically, if it's not in memcache, it'll read from disk, but then Logstash can actually inject it in the memcache for you. So it's really cool. This is just doing a get, a check, but Logstash can do a, hey, if it's in memcache, pull it. If it's not in memcache, pull it from file, but then push it into memcache with a put. And so our config files that we do, the full complete ones, it's basically get, but then it'll do something like, well, if the threat Intel score field exists, which is what that's stating, do this, which we wouldn't need to do anything, or then we'll do the lookup from file, but then push it in a memcache. So here we go. It's running. I'm going to do 10.5.55.2. Notice it has a threat intel score of 99. Where did that threat intel score get from? This is just a demo. I made it up. Watch 10.55.55.3. 10.5. We'll just do 1.2.3.4. There's no threat score because I didn't put it in my demo data set. This is where you can start to do things like MISP, Logstash, Memcache. I didn't write this, someone else did. It's a really good project. I believe it's this link. Yeah. So basically what this person's doing is they have a Python script that pulls threat intel feed data from MISP and they throw it in Memcache. And then Logstash queries Memcache. That is a super high-speed, blazing fast lookup service. So you could do this also with things like the collective intelligence framework. The collective intelligence framework technically stores all of its data in an Elasticsearch database, and it'll download hundreds of gigs of threat intel feed. For that, you would really need to use the Elasticsearch Lookup, which we showed earlier in our Windows example. Let me stop this. So in the enrich folder, Windows, how you would query this is just with Elasticsearch, you'd query it. But let's say you did the collective intelligence framework. You have like hundreds of gigs of data. I wouldn't necessarily want to throw that in Memcache because I don't have hundreds of gigs of RAM on one box. Well, I do, but you might not. If you have it, sure, why not? But if I don't do that, Elasticsearch is super fast. But if I'm doing 50,000 queries a second against it, it might not be fast enough. In which case you might need to move the data into something like Memcache. So I might selectively say maybe 500 gig of data is here in Elastic for threat feeds, but roughly 50 gig of this that we really care about, that's this special category, that goes into Memcache. So Memcache is one of the fastest ways I found to query within Logstash. All right. Check. I'm going to show Ruby, and then time permitting, I'll show this bottom one too. The sim lookup was Elasticsearch, by the way. So Logstash, this is in the tactical folder, Ruby. In your tools, you almost always have a fallback capability. In Logstash, if there's something I want to do and it doesn't support it, I can natively call Ruby code. So in this one, I'm just doing a simple calculate the length of whatever field I pass it, but I'm also doing base 64 decoding. Ooh, this is kind of cool, right? Splunk, they have Python. I wish I would have had that one. No. So there's always some type of fallback programmatic language. Like I was recently parsing some Google Cloud logs from one of my clients, and it was this very nasty JSON nested subfields with arrays of arrays, and it was a mess. And so we had to flatten the data. And what I did is I used Ruby code to grab the arrays and flatten them out so we could properly search in Kibana. So it was the fallback language. So what I'm going to do here is I'm going to use a tool called CyberChef, for example. CyberChef. And I'm just going to do, this is the most awesome technical breakout ever, right? And I'm going to convert it to base 64. That'll be my string. Hopefully this will work. I'm going to paste it here. Oh, snap, it works. So notice I started with my message. I used a regex of this to grab potential regex which stored it in this possible base64 code, and then Ruby decoded it for me. This is the most awesome technical breakout ever. So Ruby is the fallback language within Logstash that I can do anything I want that Ruby supports, which most programming languages can do pretty much everything. It's just some are easier at certain things than others. So there's Ruby. I'm going to do one more, and then I'll open for questions. Even though there's technically more stuff in here I could show you, I want to open the floor here in a second. The multi-field lookup call. I think I have to edit this one just a little bit. This is one of my favorite use cases, though. Code. This is probably the KV filter example. No, not that one. It is the dynamic. Dynamic. Yep. I'm going to change this for a second. We'll just play it like this. I'll just run it. I'm actually going to, I'll do it where it does a generator, but then lets me type as well. What I like to do for some of my clients is I like to have them set up a PowerShell script that will connect to Active Directory, grab data about special users like domain admins or sensitive groups, and it dumps it to either a JSON, a CSV, some type of file that I can then do a lookup against. And let's just, as an example, let's say one line in that file said something like this: J Henderson, comma, or pipe, and then their information. If I receive something like a logon related to J Henderson, it would then pull in via the translate plugin I showed you with the Alexa Top 1 Million, the data on the right. Now, this data, though, is a key value format. Key equals value. Key equals value. And the reason I have them pass it to me that way is they can give me multiple pieces of information from this user without having to do more than one translate. Because otherwise what would happen is they'd have a file that would look like this: J Henderson, domain administrator. J Henderson, ITO2 is their computer. J Henderson, in this case, the username would be Justin Henderson. And I'd have to do 3 different lookups to pull in that information. Well, in this, if with their PowerShell code, they outline it in this format, I can dynamically pull out all the data using key value pair extraction, which is this. Let me show you this in use. I'll just do it over here. Logstash -f tactical dynamic. So what it's going to do is it's going to act as if the user entered this information. It's going to auto parse the data because it's in key value format, all 3 of these fields. And then based on that, it does a little bit more tagging just because I like to show examples. So give that a second. While this is running, I'm looking at the Discord channel. I'll bring up the chat for Zoom here in a second. But if you have questions about any of this, I'll start taking them here in just a second. Here it goes. Full screen this. Oh, crash. Epic failure. Let's see if I can figure out what's going on here. Error, failed to execute. Notice Logstash is, oh, I know what it is. Right here. In my dynamic config, I'm outputting to a variable, and that variable doesn't exist. Let's just get rid of this. Rerun. Don't worry, everything's under control. In this example, I'm also showing metadata fields. This field I'm adding, and it would never be sent on to your syslog server or SIM. It's just a programmatic field I can call within Logstash, but it's not part of the permanent log. So this dynamic config example, I'm just walking through multiple things. Give that a sec. Here it comes, and come on, do I have it? And yes, perfect, it worked. So started with this, but through the enrichment examples, all of a sudden I pulled the user, the group that they're a member of, And then I also pulled out test data and their computer account. So Active Directory PowerShell dump, bring it in, do a lookup, and pull out all the fields. Dynamic enrichment here. That can be fully automated because anytime that CSV or JSON file gets dumped from PowerShell, this will reload it on the fly, like it's a hot reload. So this, we got 9 minutes left. This has been my technical workshop on doing enrichment to make alerts much better. I hope this is kind of getting the brain juices flowing, kind of showing multiple use cases of what you can do, kind of why you might want to do them. Any questions at this point? I'm looking on Discord. Let me bring up the chat window. Chat. So where can we see the recording of the webcast? This will be on the SANS. Well, SANS for the webcast link you joined to get to this event will probably have maybe a full recording. I plan on taking a recording of the breakout sessions I do, and I'll put them on YouTube separately, and I'll post them on Twitter. So if you follow my Twitter account, which is @SecurityMapper, and John posted this in here earlier too, I will post that later, a link to a YouTube video of this technical breakout. And I'm pretty sure Ismail is going to do the same, as well as John might do it for all of them anyway. So are y'all getting the value on why this type of enrichment could be very helpful in the sim? Anybody? Go back to, thank you. I'll go back to the best example I know is the first one we kind of started with. The 2 alerts, what they started with versus what they look like with enrichment, way different. The open source SOAR platform I'm building this year will be called Reflex SOAR. It's not ready yet. I don't want to release something until it's primetime ready. It will be able to do a lot of this as well, which will help because then if you're Splunk, QRadar, Logarithm, Elastic, and you're sending alerts to that SOAR platform, because it's going to be case management plus SOAR, you'll be able to do a lot of this stuff with that. And then if you need to write a new plugin, that will be pure Python. All right. So then I'll monitor chat for a second to see if anybody's got any more information. Other than that, I'm going to drink my coffee that I got, but I haven't drank. And here in just about, I think we're up on break. Yeah. So if you're done here, is that program still a first quarter release? I'm hoping. So you're talking Reflexor. I'm really hoping it's probably going to be more likely March because we got it up and working and it was great. But then when we started doing performance testing, it bottlenecked and I want it to be enterprise grade. Like we're going to use it for our MSSP service internally. And I don't know, I'm a stickler for quality and it just wasn't yet ready. So we're rewriting the back end to be more efficient. All the functionality I thought was really good, but I want the performance to be there. Yeah. Okay. Well, if you're done here, we're just doing a shorter lunch and then we'll come back and we're going to do the non-technical roundtable followed by the stress talk, the non-technical roundtable, and then I'll show you around the farm. Enjoy lunch break and we